Hello everyone. So today we are going to start the exercise 7.6, that is integration by parts concept, right? So the question number first here we have given here, just one second. First question, integrate x into sin x. That means here we can see I am assuming it is equal to I. So I is equal to product of the two functions. One is x and another one is sin x, right, into dx. So whenever we have the functions in the product, what actually we are doing? We are applying the product rule, that is called as the by parts. So here we have to decide which is the first function and which is the second function. So according to Eilert rule, here we are deciding the second function. So if you see here, algebraic function is before the trigonometric function. That means this is our first function and this is the second function, right? So now apply the formula or by parts concept. So x first function outside, integration of the second function, that is sine x into dx, minus integration here in bracket derivative of the first functions, that is d dx of x, and then integration of the second function, that is sine x into dx, and then bracket close into dx. Alright, so from here, first x is outside, differentiation, so integration of the sine x is minus cos x. It is minus cos x, and here minus integration of the derivative of x is 1, and this is minus cos x into dx. So now it will become minus x into cos x, and minus minus will become plus. Here now we have just integration of cos x into dx. So it is minus x cos x plus, here integration of the cos is sin x plus c. So this is the answer of the question number first, right? Now the question number second. So the question number second we have here, second, I is equal to, here again we have the product of two functions. First is x and sine 3x into dx. So how we can do that? We can see here the x, this is our first functions and this is the second function. So what actually we should do? We have to apply the by parts. So according to the by parts, first function outside, integration of the second functions will become minus cos. So here I am writing minus cos 3x, directly I am writing here because already we have solved one questions, right? And then minus inside integration derivative of the first functions, this is 1, and integration of the sign will be, so this will become plus sign, and then it is going to become cos 3x and divided by 3 into dx, right? So now finally 1 by 3, and again one more 3 will come from here. So here it is x cos 3x and divided by 3, and this differentiation of the cos is sine. So it is sine 3x, and 3 and 3 will become 9 sorry, plus c. So this is the answer of the question number second. Now we'll move to the next question, that is question number third. So the question number third, here we have I is equal to integration of x square e to the power x square e to the power x into dx. How we can integrate it? As we can see here, exponential function. This is first function if you see the Eilert rule, and e exponential function is always the last, right? So it is second function. So first function, here we are writing first, here this is equal to x square, and integration of the second function, that is e to the power x into dx, minus integration, inside integrations derivative of the first functions. That means here d dx of x square, and then integration of the second functions, that is e to the power x dx into dx. Right. So finally, what we are getting actually x square. This is e to the power x dx will become now, because integrations we have taken, so no need of writing the dx, means here I need to erase it. There is no dx. So now we'll continue. So it is, why the pen is not good? Plus, sorry, minus. Inside integration, it is 2x and it is e to the power x and then dx. Right now, again, we can see here we have the two functions x and e to the power x. That means here we have x square e to the power x and minus 2 outside, and we have to apply the integration for this x e to the power x. So x is outside, integration of x is x, and then minus inside, integration of derivative of the first function x is 1, and this is e to the power x into dx. That means here we have x square e to the power x minus 2x e to the power x plus e to the power x plus c. This is the answer. Right? Now, what is the next question? So the next question is question number 5. Sorry, 4. Here we have given I is equal to integration of x log x into dx. So according to the ilet rule here, which is the first function and second function, ilet, L is coming first. That means this log is the first functions and this is the second functions here. So first function will be outside log x and integration of second functions, that is x into dx, minus inside integration d dx of first functions, that is log x, and then again integration of x into dx, bracket close, into dx. So finally log x will be as it is, but differentiation integration of x is x square divided by 2, minus here integration of log x, derivative of log x is 1 by x, and here it is integration of x is x square, right, and here we have 1 dx. So this x square and this x will get cancelled out. That means here now we have log x and x square by 2, and here we have just integration of x, so integration of the x is x square by 2 plus c, x square by 2 plus c. So we can see here x square is common in both, so we can take this x square by 2 common. So if you are taking x square by 2 common, it will become log x minus 1 and plus c. So the question number 4 also done. Now we will move to the next question, that is fifth. So what is the question number 5? We have given here I is equal to, that is integration of x x log, this time it is 2x, right, into dx. So we can do it little faster this time. Means here we will write log x is the first function here. So log x outside, and actually it is 2x, log of 2x. So just let me erase it, let me write properly. So first and second functions here, we know this is the log is the first functions and x is the second functions, right? So here this log x second functions as it is, and differentiation of the x, sorry, integration of the x is x square by 2, minus here inside integration, derivative of the first function, so that is 1. Sorry, derivative of the first function, that is here it is log x. So it will become 1 upon 2x. It is 1 upon 2x, and then by chain rule, here it is 1 upon 2x, and by the chain rule, it is 2. Differentiation of the 2x is 2. And then integration of the x is x square into dx. So here this x square and this x will cancel, this 2 and this 2 also will get cancelled out. Means here we have, here we can write it as this is x square log 2x log 2x, here x square by 2, and minus, just we have x here, so it is x square by 2 plus 3. Correct? So this is the answer. Here again we can take the common as x square by 2, means here if we are taking the x square by 2 common, so we will have remaining log 2x minus 1 plus c. Right? Now next question, that is question number 6. So the question number 6, here we have given I is equal to integral x square into log x. X square into log x means same concept. Here we have two functions, log and algebraic function. So log is the first function and this is second function. That means here it will become first function outside log x, and integration of x square is x cubed by 3. And here then minus inside integration, derivative of the log x is 1 by x, and x square integration is x cubed by 3 into dx. So this x power will become 2 and 3 will come outside, means from here we have log x into x cube divided by 3 minus 1 by 3, and here again one more 3 will come, so 1 by 9 and x to the power 3 plus c. This is the answer of the question number 6. Now we'll move to the next question, that is question number 7. So in the question number 7 we have product of x and sine inverse x I. This is actually, so 7 I will write in the next slide only because it will take time. So we'll move to the next slide for the 7. Here, question number 7 is I is equal to integration of x into sine inverse x. Now here we need to decide first and second functions. So how we can decide it? According to Eilert rule. Eilert rule. So Eilert, that is inverse. So inverse is the first function, and this algebraic is the second function x. So how we are doing that? First we are writing the first function outside of the integration. So sine inverse x, and then integration of second functions into dx minus inside integration derivative of dx of the first functions, that is sine inverse x, and then after derivative of this integration of the second functions, that is x dx, and then bracket close into dx, right? So from here now this is sine inverse x, and here it is x square by 2 minus integration. What is the derivative of sine inverse x? So it is under root of 1 minus x square. Under root of 1 minus x square, and differentiation of x, sorry, integration of x is x square by 2, x square by 2 into dx, right? So here it is 1 by 2 x square by 2 sine inverse x minus here we can write this 1 by 2 outside and this is x square and here it is under root of 1 minus x square into dx. Now we have to integrate this part. How we can integrate this x square? By under root of 1 minus x square. So we need to think of this part. So we have given x square. We want to apply the here rationalization method. Means we can do here, we can make this, we can take this minus x here and then we will add it. Means we can rewrite this equation as here x square by 2 sine inverse x minus, I make it as plus because I'm going to take this minus here, minus x square. And here I'm going to add plus 1 and subtract the minus 1 and then divide it by under root of 1 minus x square. Divided by under root of 1 minus x square into dx. So this is one term and here this will give the another term. So from here what we are getting finally x square by 2 and this is sine inverse x plus 1 by 2 and here we have 1 minus x square and this is divided by under root of same thing, under root of this into dx, right? And again we are taking separately 1 by 2 for divided by 1 by under root of 1 minus x square into dx, right? Now here if you rationalize it, means if you multiply with under root of 1 minus x square by under root of 1 plus x square, that means this root will get cancelled out and 1 minus x square will get cancelled out. We will get here finally here it is equal to x square by 2 sine inverse x plus here after simplification we will get under root of 1 minus x square, under root of 1 minus x square into dx and here we have minus 1 by 2 under root of 1 by, actually here we could write the answer also directly because it is directly formula. So these are direct formulas based, right? Both are direct formula based. So here we can write the answer as the answer of this integration I is equal to, first of all, it is x square by 2 sine inverse will be as it is. Sine inverse x as it is. Now, what is the 1 by 2 here outside? And what is the answer for this under root of 1 minus x square? Under root of 1 minus x square, it is x by 2. Here inside bracket, I will write x by 2 as it is root part 1 minus x square and then plus sine inverse x by a, sine a square by 2 sine inverse x by a. So a square that is 1 only. So here 1 by 2 and sine inverse of x by a, that is sine inverse x. Here this is for this under root of 1 minus x square. Now this second one is sine inverse x. So here actually this is minus sign. So here minus 1 by 2 sine inverse x. Right? So just one step we can do now. Here we can multiply this 2 with both and this 2. Right? And this will be our answer. So now next we'll move to the question number 8. In the question number 8 we have, just one second. Uh, eighth question, I is equal to we have given integration of x tan inverse x. This time we have given tan inverse x into dx. So how we can do that? Exactly same way how we did for the sine inverse. Here it is our first function and this is our second function. So first function outside, tan inverse x outside, and here we are going to take the derivative of the x. So integration of x will give us x square by 2 minus integration derivative of the first functions, that is what is the derivative of this 1 upon 1 plus x square, and integration of x is x square. So we are getting this, and now into dx. Alright. So actually it is simple. Tan inverse x, and here x square by 2. Here inside this we have minus sign and taking the bracket so that we can add and subtract the things here. We have x square here because it is multiplied with the 1. So I am going to add plus 1 and subtract minus 1 and divide separately with this denominator. So here divide it separately with 1 plus x square. So you can see clearly here we have actually integration sign also here common for both. So into dx. Here also we can take the integration separately. This becomes 1 and now we have just minus 1 means now we have tan inverse of x into x square by 2 minus here inside bracket we have integration of the dx minus outside and integration of 1 upon 1 x 1 x square is tan inverse x. So this is tan inverse x, right? And here I am writing this bracket close for now, and means finally our answer will be here. This part actually here we have applied the integration according to that we wrote. I wrote this answer. So it is tan inverse of x and then x square by 2 as it is, and from here we are getting just x, and this will become plus tan inverse x plus 6. So we will do two more questions, that is question number 9 and 10. Just 1 second, why it is not going up. Mm-hmm. Mm-hmm. So here, so the question number 9 we have. What is the question number 9? We are given I is equal to integration of x cos inverse x. It is cos inverse this time. All are the inverse trigonometry base. Right. So here again we can decide the first and second function. What is their first function? So the cos inverse is the first function and x is the second function. All right. Now what we can do? We will take the cos inverse x outside. So it will become cos inverse x, and integration of the cos x is x square by 2 minus integration of inside integration derivative of the cos. So derivative of the cos we know that minus 1 by under root of 1 minus x square, that we know, and integration of the x is x square upon 2. All right, here into dx. So now what we can do, this term as it is cos inverse x, and here we have x square by 2. Minus minus will become plus. Here again same thing what we did for the sine we can do here, means here just minus minus become plus. Now we have just 1, so we are going to 1, or actually it is just we can say we have x square. We have x square, but we have to make this x square as minus. So here we are multiplying with minus sign in the numerator and denominator. That means this is here also I am multiplying with minus sign. So this is as it is into dx. Next, this cos inverse x and then this x square by 2 here plus, and because of this minus I'm just converting this plus into minus, and here I'm going to add plus 1, so plus 1 minus x square and then minus 1, and this is divided by under root of 1 minus x square, and here also it is divided by under root of 1 minus x square into dx. Right? Now we can take one bracket also to avoid any confusion. Huh? Here we have a bracket. Now what we can do further? This x square by 2 outside, and it is cos inverse x. Alright. Here inside integration, inside bracket, if you see, here I am taking bracket, and what we are getting, if you rationalize this part, this will give only under root of 1 minus x square. And here we are getting minus 1 by, here also I am taking separately root, under root of 1 minus x square like this. So here out of this, I'll write dx, that is for both. Right now, we have to write the formulas for this. What is the formula for this? So here it is x square by 2 cos inverse x minus under root of 1 minus x square. Under root of 1 minus x square. So here the answer will be x by 2 under root of 1 minus x square plus a square by 2. A square by 2, that means 1 by 2, and sine inverse x. And from this, if you open the bracket actually here, it will become minus minus plus sign, and from here we will get sine inverse x. Sine inverse x plus c. So this is the answer. Here we are getting actually the sine inverse x. We can convert the sine in the terms of cos, and we can write our final answer in the terms of the cos. In terms of cos, like 2 sine inverse we are getting here inside. So we will simplify this first, means we can rewrite this as equal to x square by 2 cos inverse x. If you open this bracket here, it will become x by 2 and under root of 1 minus x square, and here it will become 3 by 2 sine inverse x. All right, because 1 by 2 plus 1, or actually it is minus, right? So it is minus sine 1 by 2 and this is plus, so it will be 1 by 2 only. It will be 1 by 2 because minus 1 by 2 plus sine inverse x will be 1 by 2 plus 1 by 2 sine inverse x, right? This is also answer, but we can convert the sine inverse in the terms of the cos inverse. For that, what we need to do? Here we need to just apply the trigonometric concept. We can write this sine inverse x is equal to pi by 2 minus cos inverse x. Pi by 2 minus cos inverse x. Over here we have the identity from the inverse trigonometric, so that we will apply here. We will write it is x square by 2 cos inverse x minus x by 2 under root of 1 minus x square, and here plus 1 by 2 as it is, but in place of sine inverse we can write pi by 2 minus cos inverse x plus c. So here we have cos inverse, here also we have cos inverse. And now finally we can rewrite our answer x square by 2 cos inverse x minus x by 2 under root of 1 minus x square. And here plus it will become pi by 4 minus 1 by 2 cos inverse x and then plus c. So this is the answer. Now we'll move to the next question, that is question number 10. So the question number 10 here we have 10 I is equal to what we have given here. So this is equal to sine inverse x whole square. Whole square is given. Sine inverse x and then whole square integration into dx. How we can do that? If we are assuming sine inverse is equal to t, then it will become. So do we need to assume it with this some variable or directly can be applied? There is only one constant, right? Mhm. We have to multiply this with one more constant. So we are multiplying with this with 1. Means we are writing it as integration sine inverse x whole square into 1 into dx. So sine inverse, this is first function, this is second function. That means here we will get I is equal to sine inverse x whole square. Sine inverse x whole square and integrations of 1 is 1. Integration of the second function, sorry, of integration of the second function is x actually. 1 into dx is x minus here derivative of the sine will be 2 times of the sine inverse x and then derivative of the sine x that will be under root of 1 minus x square and into and actually here we need to then take the this is the derivative now integration of the 1 into dx that is x into dx, right? Now what we can do here, we have to apply the substitutions method. If you take the sine inverse x is equal to t, then what we are getting, let for this part only, let us suppose this we are considering this is equal to our I1, right? So we are going to simplify this I1. So in I1 we are substituting sine inverse x equal to t. Sine inverse x equal to t. That means from here we will get 1 by under root of 1 minus x square into dx. This will be equal to dt. Means now this our answer, the final answer I will become 1. I will be here I1 actually. I1 will be here. We have 2. I'm writing outside as it is, but it is sine inverse of. So sine inverse is t, and here we are getting dt. But we have one x also. So x equal to what we can say sine t. So sine t means actually we should write like this 2 times of the t sine t into 2 sine t into dt. Now we have to apply the integration of this part. So 2 as it is and here t is the exponential I late rule a is coming first. So first t is the first constant, t will be as it is here. Integration of the cos the sine is minus cos. So minus I root. Here it is cos and then integration derivative of the t is 1 and integration of the sine is cos t into dt. Right? That means here we are getting minus 2t cos t and integration of the cos is sine t. And plus c means here we are getting minus 2 t means what? So t is sine inverse x. Sine inverse x. If t is equal to from here we are saying sorry x is equal to tan inverse x is equal to we say sine t, right? X is equal to sine t, that means what is the cos t? Cos t will be equal to under root of 1 minus x square. By applying the identity sin square x plus cos square x is equal to 1. That means here we can replace the cos t with under root of 1 minus x square. 1 minus x square, and then sine t is equal to, we know that sine t is equal to x plus c. So finally I will be equal to what? So I is equal to x sine inverse x whole square minus 2 sine inverse. Actually, this 2 will be multiplied here. 2 is common here. You see, 2 was here multiplied. So this will be multiplied here and it will multiply with constant also, but that doesn't matter. So it is minus 2 sine inverse x and root 1 minus x square minus 2x plus c. So this is the answer of the question number 10. Thank you.